Hello everyone, welcome back to our channel. In this series of video, we'll be discussing about the question bank and answer tips of 21EC53 Computer Communication Networks of Module 3, that is your network layer. Come, let's go into the video. Please do like, share, subscribe and comment. Moving on to the first question, demonstrate the IPv4 datagram format with neat diagram. So Internet Protocol version 4 datagram format. So this is the datagram format IPv4 version, hardware length, service type, total length, payload length, identification bits, flags that has been erased to make sure that whether the bits are overflowing. D and M is the flags and one is reserved, and fragmentation offset, header checksum, what kind of protocol, time to life, that is the number of hops taken by the frames, source IP address, destination IP address, and there is an option with padding values. So here the original payload will range from 20 to 65,535 bits and your header will be 20 to 60 bytes. So this is the format that you will be drawing and each and every block will be explained neatly. Second question, explain link state routing with its link state database. So here is the database, that is, here is the circuit network graph that has been drawn, and this is the link state database. So how it has to be created is A to G, you have the path. So A, B, C, A from G you will be writing. Here also A to G you will be writing. So A to A, the path will be 0. A to B, here you can see it is 2. And A to C, there is no direct connection, so it is infinity. A to D, there is a direct connection, 3. All others become infinity. Likewise, for B, C, D till G, you will be forming a database. Now, after forming the database, what you have to do is you have to calculate the node and cost for each of the every node. So, for A node, what is the node that is being connected is D and B. So, B, D, what is the cost, respective cost? For D, E, B, C, for everything you will calculate the cost, and then you will calculate which will be the shortest distance to connect based on this cost and determine the link state routing. This is link state routing algorithm. So moving on to the next question, an organization is granted block of address with the beginning address. So this is the address that has been IP address that has been provided. Now the organization has 3 subblocks of address. So how? One subblock will have 10 address, 60 address, 120 address. So here I have been designed for 120 address. So here you can see 120 will not be the direct power of 2. So 2 to the power of 6 is some other value, 2 to the power of 7 is 128. So we have to consider a block which is having 128 or more than 128. So this is 2 to the power of 7 gives 128. So what happens is, this is the formula, 32 minus log 2 128. So 32 minus log 2 128 is 2 to the power of 7. So here log 2 and 2 gets cancelled, log 1 is nothing but 1, and then 7 comes here in front of 7 log. So 32 minus 7 is 25. So your first address will be calculated for 25 and last address for 25. So this is your first address and last address. The same way you have to calculate for 60. So 2 to the power of what gives you 60. Then 32 minus log 2 of 2 to the power of what gives you 60. So that will be minus, and the value will be different for 60 address. With that corresponding value, first and last address will be found. Then moving on to the next question, illustrate the forwarding process of router. So we all know that the network layer is responsible for routing the data. So forwarding process is nothing but you will have a set of networks with forwarding table for each node, and make sure that the routing algorithm updates the header value, that is your port number and the IP address in the forwarding table. How it has been updated for each and every frame of data that has been sent. That will be explained here with this diagram. Next question, calculate the shortest path from source A to destination G from given graph as shown in the figure using Digitra's algorithm. So here you have from A to G with different cost, and you will be finding the shortest path. How you have to find is, you form a table like A, if you are calculating for A, then form B, C, D, E, F, G. Calculate that. Now you start writing A to B, which is the shortest path. 2 will be the shortest path. You have other routes also, but this will be the shortest path. and then A to C, which will be the shortest path, either this or this. You keep on calculating and writing. When you calculate, you will know which is the shortest path. That value has to be written from A to C. That is how you will be calculating your digit loss algorithm iteration process. Yes. Next, interpret distance vector routing using Bellman's-Ford algorithm, providing a suitable illustration. So Bellman's-Ford algorithm is nothing but the minimum distance that has been calculated. So this is the intermediate nodes A, B, C, XY is the node. So here you can see CXA, how it has been calculated. This is the cost and this is the distance. So cost of one node, that is CXA, plus your distance will give the Bellman's-Ford algorithm. That is your Bellman's-Ford algorithm. That will give you the minimum distance. So this is the minimum distance that has been formed out of this three intermediate nodes. This is the new path. So the value will be dxy is equal to minimum path of dxy is nothing but cxy plus dxy. Yes, this is how you calculate Bellman-Ford's algorithm. That comes under distance vector routing. You will be calculating the distance and routing the packets or frames to the particular destination. Hope you have understood the tips. Please stay tuned for more information. Thank you.